This is Ishwara Goyal.
And I'm Nilesh Agarwal.
Hey, I'm Harsha from PathAI.
So Nilesh and I, we are from Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Harsha from PathAI with us today. He's a seasoned technology leader and is currently serving as a director of machine learning at PathAI. PathAI's mission is to improve patient outcomes with AI-powered pathology. It's a Series C funded company backed by marquee investors like General Atlantic, General Catalyst, etc. Thank you, Harsha, for joining us today.
Yeah, thank you. Very excited to discuss about how we apply machine learning to pathology space.
Awesome. So we would like to start the interview, Harsha, by understanding first that what kind of business problems are you solving through AI?
Yeah, at PathAI, we develop AI products for histopathology, mostly focusing for oncology and non-oncology areas. And these products that we develop helps pharma companies in discovery of novel biomarkers, as well as help pathologists in diagnosing or scoring different types of diseases in the pathology image granularly. And mostly these products are help pharma companies and pathologists in terms of translational research, clinical trials, and diagnostic space. And one of the main challenges in this space is these histopathology images are a piece of tissue taken from the patient, and these are scanned by these high-resolution scanners, resulting in something called as whole slide image, which are gigapixel size images. And these images can be in the range of like 100,000 by 100,000 pixels. So it's a massive image per patient. So we have to build algorithms to segment these images, identify different cells in these images, and separate the tissue of cancer and tissue of normal, and ability to identify new biomarkers in this image and share that information to pathologists as well as to the pharma companies. Is the main interesting challenge for us to develop machine learning algorithms for.
Very interesting. And how do you currently deploy these models in production? Like, do you work with managed services like Hugging Face, AWS, or have you built your own ML infrastructure from scratch? Would also like to understand your thoughts on the pros and cons of either of the approach that you have taken.
Yeah, this is a very interesting question. Like we started developing our infrastructure like back in 2017. So our journey has been very interesting how we evolved over time. And when we started, we had mostly like the in-house infrastructure that we wanted to build. So we have in-house infrastructure for separately for training and inference. So for training, we have our own data center as well as our computation server that we use to train our models. For inference, also for majority of use case, we use our in-house infrastructure. For some of the use cases, we use AWS to deploy these models. As I described, one of the main challenges here is this massive size of these images. So for us, we needed to build custom infrastructure to support and optimize how we deploy our products on these images, as well as for the training. We have optimized our infrastructure separately for the training and inference. As I described, like these images are massive. So the way we build our products are composition of sub-models, and each model is again a deep learning model, which are again computation heavy, as we all know. And we deploy one of these models in parallel sequence, and then segment these images into different regions, and then aggregate them back in ability to generate some slide level or patient level information. So all of that requires a significant amount of workflow orchestration and optimizing the inference, utilizing the GPU and CPU effectively to get those outputs at low cost for our internal like batch processing or for close to real-time processing.
Got it. And like, do you guys use something like AWS or GCP, or like do you have like an in-house like deployment of these models?
So for 80% of like most of our training, all the training happens in our data center. So we don't use AWS. The storage, some of the storage is in AWS. And for inference, 80% of our use case again is our own data center and in-house infrastructure. And for some use cases, we use AWS.
Got Got it. And do you then have also your own like Kubernetes? Like, do you manage all these deployments on Kubernetes, or like are you running some other open source software there?
Yeah, so our workflow orchestration is built on top of the Argo and Kubernetes, and uses auto-scaling to scale within our data center, or we have the same infrastructure that applies to AWS as well to support different types of nodes and ability to run different types of models on GPU or CPU and so on.
Got it. No, this is pretty interesting. And when you deploy them like to these, let's say, Kubernetes machines, so do you also run like conversion pipelines to, let's say, ONNX, TensorRT to get like better optimization, faster latencies, or do you deploy them in the native format? Just wanted to
Yeah,
understand your experience with quantization.
yeah. Like we have experimented with different ways to optimize the inference and to get to like the optimized inference and low cost and so on. But in our case, like what we have noticed is like understanding our use case is very important, given like what we work with pharma companies where the real-time processing of any image is not a must-have requirement. So for us, like deploying in native format is good enough to serve the requirements we have. So most of our deployment is in native format and all our models are in PyTorch.
PyTorch, got it. And as you also talked a little bit about like different like batch processing versus real-time processing. So just wanted to understand like, is the infrastructure different from them? How have you handled the different cases? And do you have like also streaming as a part of this, like where some data is like based on a stream? And did you guys build the infrastructure or did you like use something like which was open source for that? Just wanted to understand that part.
Yeah, that's a good question. So I can explain as two use cases. One is batch processing. One is the close to real time. I will explain why it is not completely real time as well. So share those results with our customers. So for that, we mostly use our in-house infrastructure to deploy. And where we have optimized how to run different models on different GPUs on our data center and what time, which are GPU based. And then aggregating results from these models can be CPU based tasks, and those can be run on CPU environments. So we separate in our workflow orchestration where we send out this computation for different nodes and then aggregate them. And this aggregation can vary if you're doing a batch processing versus if you're doing like a one slide or one image processing steps. If we go to the close to this real time aspect of it, so we deploy our models to be used in a lab setting. It can be in clinical trials or diagnostics for research purposes. So in those cases, there is a technician who takes this glass slide and they scan it through the scanner, and then they have this massive image file. They upload this file to our server or our storage. Then we deploy the model, and we have the computed results already for the entire slide. And then there is a pathologist who comes and looks at the original image as well as the model results. And then they can interact with the model. So until here, because the technician uploads, let's say 1 day before, so we have almost 1 day to run the model and get the results. So we try to understand the user workflow so that we want to reduce dependencies of a requirement of getting to real time. So we wanted to reduce that real time dependency. So we optimize the workflow, how the technician uploads the image and how pathologist is going to review. So we created a lag in between that. So that gives us a lot of advantage in deploying models at low cost with a significant time, can be multiple hours. So we are not in a urgency to create something real time. But we have the later stage where once these results are shown to pathologists, they can interact with the algorithm. They can say, hey, algorithm has made some mistakes on this region. So I want to exclude this region in computing this slide level, or patient real-time interaction happens on the CPU nodes with very less computation. And that is the area we optimize a lot in ability to get close to real-time results back to the pathologist when they're interacting with the algorithm.
No, this is pretty interesting, and especially the part that you also tried to insert something kind of a pre-cache so that your dependency on the real-time model prediction also does not like is not there too high, right? So they can be used multiple times, but the infer function just has to be called once, and then you probably save the data in a cache which can like serve multiple people. Pretty interesting. And so just wanted to understand, as you are using PyTorch for your like most of your models, right? So are you using something like a Torch script, or have you written your own containers where you deploy it, which also interacts with the workflow tools, or like are you like what are you using to like launch these model containers? Wanted to understand.
Yeah, majority of it is our own custom wrapper on top of the PyTorch code, and we use TorchScript also for some of the use cases. But majority of it is our own wrapper on top of it to support our containers to enable the deployment and inference.
Got it. And is the workflow orchestration tool that you guys have also written, or are you using something there?
Yeah, we use Argo, but we wrote a wrapper on top of Argo that enables us, like we have, like for our ML engineers to be able to easily interact and give a notion of like our custom like requirements and like tasks, like what we define as these images, what we define as models, how to define which one go to GPU, which one go to CPU, to make those things very easy. And also we have the same stack that can work for both AWS or for our data centers. So that wrapper gives us that ability to abstract it away from ML engineers, that they just ask for the set up the requirements in these tasks, and then we execute them independently, either on AWS or on data center.
Got it. No, pretty interesting and good. It's like helping other developers also like ship model machine learning models. So just my last question before I'll hand it over to Aishwarya. So between like latency of the model and model accuracy, right? So let's say, for example, you can have a very large model which has a like a very slow latency, but also a very small model which has a very like low latency, right? So in that case, like what is your preference in terms of which kind of a model as an organization or as a directive in your team do people choose, and like how do you achieve the desired goal with that?
Yeah, as you know, we work in the healthcare space in the cancer area, so we want accuracy to be the highest metric that we care about. So that's where we try to understand our use case, understand the user workflow, understand the business case, so that we try to reduce these latency needs. As I explained previously, setting up this pre-cache would enable us to like deploy any large model to get the results, even if it is longer, and adjust the user workflow to get the most accurate models out there. So for us, like the accuracy is the important factor. But again, there are research use cases where we try to balance it out in terms of what we need. But majorly, like we try to reduce latency and dependencies. And sometimes we make those trade-offs in some cases where we are doing some level of aggregation. For example, if you, as I was talking about, where paths are interacting with the algorithm, that's where we try to make those trade-offs. And even if we prioritize accuracy over latency, find ways to reduce the latency in needs as much as we can.
Got it. Pretty helpful, yeah.
Yeah. No, I think very interesting, Harsha. I think good to hear about all the techniques that you folks are using. So my question is around auto scaling, right? So how do you manage like and scale your infrastructure for inference as your usage grows?
Yep. So yeah, within PathAI, we have our own ML infra and ML ops team who works on this infrastructure. And they manage the auto scaling piece of it, and we use we use the same auto scaling infrastructure that helps both in AWS, even in our data center. So depending on the load we are getting, we try to manage that. And we have some challenges, especially with our data center, how we manage that load and so on, where we are creating queues and priority over which ones to run, which ones to slow down, and so on. So auto scaling is what we use both for our data center and AWS. That's maintained by our ML infra team.
Got it. Got it. Makes sense. And finally, would like to also understand, like, do you have any suggestions in terms of like best practices that you would like to recommend other ML engineers who are looking to deploy their models in production based on your experience?
Yeah, so based on my experience, like when I started as an engineer, like majorly I was thinking of getting everything to perfect in terms of like latency and accuracy, all of those things, which becomes a challenge. And one thing that I learned through some of the challenges on my own was, along with the experience in PathAI, is understanding the business case, understanding the use case helps you a lot and gives you a lot more levers to optimize, not just the ML inference code, but the product overall. So understanding the product use case could help engineers to identify alternative ideas of where to optimize and why to optimize, and help them to have those discussions with business leaders, and set up that product in a way that helps both the ML as well as the needs of the customer and so on. So mostly my advice would be to understand the business use case, understand the user workflow, and identify alternate ideas where they can use that information to build different ways of deploying these models to their needs, would be my key thing. And also, while doing that, one can really understand the requirements much more deeply, which requirements are nice to have, which are must have. Understanding that would enable you to target your work towards solving the right problems for the business, and the impact that can be created by solving those problems should be significantly meaningful to the business. So understanding the requirements, understanding the use case and the business case would help you much more in finding the right ideas and right areas to solve.
Got it. Got it. No, very interesting insights, I think, Harsh. So I think, yeah, these were the questions that we had, Harsh. Really, like found your entire architecture and approach quite unique, and which makes sense from the use case that you're also, working towards. Again, thank you so much, for taking out time for the session. I'm sure like the listeners are gonna, go away with like some interesting takeaways.
Yeah, no problem. Thanks a lot for the engaging discussion and like a lot of these questions. And we are also like always trying to improve our infrastructure, and always trying to see other existing open source stack to see what are the things that lack in our stack, as well as how to use open source tools and other tools to speed up our scale and growth.
Yeah, awesome.